Today's December 4th, and we're looking at solving proportion equations. We're going to give you a skill that will help you solve problems that look similar to this down here. 2/5 is equal to 6/15 when there's a variable in it. All right. So first of all, let's establish what a proportion is. This right here, 2/5 is equal to 6/15, is equivalent to this expression on this side over here. The 2 is to 5 as 6 is to 15. One's written in fraction form and one's written in ratio form. And if you were here last year, you experienced a lot of going back and forth between the two. So these two are both true statements. They are both proportions. And that helps us to understand that the definition of a proportion is merely a statement of equality of two fractions or ratios. Anytime you see fraction equal to a fraction, we can call that a proportion. Because as one of the fraction changes, the other one changes in proportion to it. In 5th and 6th grade, you had a lot of these ratio proportions where you had to fill in one of the missing numbers often. There's some vocabulary that we're just trying to establish with this screen that you will hear math teachers saying. So this is a proportion, and in the proportion, two of the numbers are called the means of the proportion. Just kind of a strange new term you need to learn. The 5 and the 6 here are called the means of this proportion. The 5 and the 6 are called the means. It's kind of strange. I know, it's just like learning a foreign language, though. That's what those two numbers are called. The two numbers on the other diagonal, going from your lower right to the upper left, these two numbers are called the extremes. The 2 and the 15 are called the extremes of the proportion. Now the proportion, whether it's written like fractions or written like ratios, the means and the extremes are the same two numbers. So if I want to know what the extremes are over here in this ratio proportion, look to the fractions and tell me what two numbers I told you were the extremes. Jack?
2 and 5.
The 2 and the 15. The 2 and the 15. It helps you see why these are called the extremes a little bit better, because Caitlin?
It's like the 2 and 15 are farther away from you. They're on extreme opposites.
Yeah, exactly. They are extreme ends of the problem. They are kind of extreme and opposite of each other. That means the 5 and the 6, the ones in the middle, are called the means. Any of you should be able to take a proportion written as fractions and write it as one that's written as ratios. And if you forget which word is which, it might help you easier to name them if you look at them in this format. Remember, those ones on the outside are the extremes of the proportion. Okay, so vocabulary we're just going to use as we go forward. Any questions? Let's go forward. All right, so we're going to investigate something that's interesting and that we can capitalize on in proportions here to help us solve for unknowns. So we're going to start off by looking at this first proportion, which says 3/4 is equal to 9/12. We all know that that's true. 3/4 is equivalent to 9/12. All right. First of all, let's use our vocabulary. Which numbers in this example are the means of the proportion? Which numbers? Caitlin?
4 and 9.
Yes, so let's label them. That's how we kind of build that into our brain. The 4 and the 9 are the means. And if I asked you to tell me the product of the means, what would you do? What would you do to get the product of the means, Daryl?
You multiply 4 and 9.
Good. So you do product and multiplying very pleased. Yeah. You multiply 4 times 9, and what would you get, Daryl?
36.
Good. Now let's look at the other ones. What are the 3 and the 12 going to be called? What are those? Anna?
Extreme.
Very good. These are the extremes. And what's the product of the extremes? What's the product of the extremes? Well,
3.
yeah, you got it by multiplying what? 2 factors? 4. Good. Do you notice that the product of the means is equal to the product of the extremes?
Oh, yeah.
that's just a freak coincidence or what? Let's look at another one. All right, so let's look at 5 is to 7 as 20 is to 28. Okay, which ones are the extremes? Mary? Good. I tried to mess you up by asking about the extremes first, and it didn't work. The 28 and 5 are the extremes. So what are the other ones called, Liam? The means. The means. The 7 and the 20 are the means of the proportions. All right, let's look at the products to see if this was a freaky coincidence or what. What's the product of the means, Luke?
140.
Yeah, you got it by multiplying.
720.
Good. And what about the product of the extremes? What do you multiply to get those? Will?
28 and 5, you get 140.
You get 140 again. All right, let's have you practice getting the vocabulary and checking if it happens on this last example. So with your neighbor, label the extremes and means and check the products quick.
There.
Okay, so which numbers in this problem were the extremes? Which ones were the extremes, Jack?
18 and 1.
Good, and what's their product?
18.
Good, and which ones are the means? Anna?
3 and 6.
And their product is? So once again, we see that the product of the means equals the product of the extremes. What do you notice about the product of the extremes and the product of the means? What's the sentence we could write there? Nice complete sentence. Logan?
The product of the extremes and the product of the means are the same.
Logan said are the same. We could have said are equal. Whatever word you prefer, I don't care. But you want to understand that they should be the same. Okay? All right. Now, I'd like to have you look at what these rules look like algebraically. So algebraically, in a textbook, we would see this. If A is to B as C is to D, then, Mary? Well, we're talking about the products. So you would say A times, yeah, A times D would have to equal what, Mary? B times C. Very good. That's the same thing we just saw with numbers up here. We saw that this times this equals this times this. The product of the means equals the product of the extremes. This is called the extremes means property. It's very useful for solving proportions that don't have nice friendly numbers in them. All right. Any questions? Yeah.
I just thought it was kind of funny how it's A, B, and B, C.
Oh.
But like,
Only in 4
Oh, it's like AC/DC.
What does AC/DC mean?
It's a band.
Oh.
Old rock band. All right.
Oh.
Let's apply it. That's always the key here. All right, so we're not going to do all of these, so don't work ahead, all right? We're going to skip around a little bit. Well, let's start with number 1 to get our feet under us. We have a fairly simple proportion here. D over 14 equals 3 over 4. In the past, you would solve these by looking, a lot of times you would see like a relationship. If this was a 12 down here, you would know, oh, I can multiply by 3 to get the other one. But you're going to look at lots of situations where it's not easy to see. So using the extremes means property allows us to solve them quickly. So we use this extremes means property and we write a little equation from this proportion. What do we know in this equation must be true? Caitlin?
Means and the extremes have to equal the same thing.
Good. So what equation could I write?
4 14 times 3 equals
Good, 14 times 3 has to equal d times 4, or I can just say 4d. The product of the means has to equal the product of the extremes. Now we have a little equation, and we're very good equation solvers. I just passed back homework checks you did great at. What should we do next in this equation, Mickey?
You sure that you could find D?
Okay, we're gonna find d, but what's kind of a first step we should do along those lines?
Just finish it so like the means and then put down the extreme for D equal 42.
Okay, equals 42. So if there's math in here, let's do that. 14 times 3 is 42. So this equation simplifies to 4d equals 42. And then what do we do to find d isolated all by itself, Daryl?
We have to multiply 4 times D or find the value.
Yeah, but we just want to know d, and we know what 4d
Oh, that'll
is.
be 10.
How'd you get that?
4 times 10 is 40, and we have 2 fourths left over.
Okay, that's decent mental math calculation, but if kids couldn't do that and they just wanted to solve this algebraically, what do we do when we know what 4d is? So Anna, what can we do? Yeah, divide by 4, right? Yep, and you get your d equals what you said, Daryl, 10.5, right?
Mhm.
Or it could be written what other way?
10.5.
Yeah, 10.5. Be on the lookout in the answer bank tonight on your homework that if you have one form, the other form might be in the answer bank. Any questions?
No.
Writing this equation right here is key to this lesson, especially as the levels get more complicated, all right? So we're going to skip 2 and 3, and we're going to go to a more complicated one. Let's look at number 4 together, number 4. All right, so we have n minus 3 over 16 equals 5/8. All right. We want to use the extremes means property. We want to get used to it. And it's a pretty good way of solving this proportion for n. So what equation can we write based on the extremes means property? What times what? What times what? Neil?
16 times 5 is equal to 8 times n minus 3 for 32.
Great. There's our equation. 16 times 5 equals 8 times n minus 3. What should you do next? What do you want to do, Luke?
6 times 5.
Is equal to? Good. And what can we do on the right side of the equation, Anna?
You divide by 8n minus 24.
Good. So Anna distributed. Okay. Now it's a little couple step equation, Mary. Okay, add 24 to both sides. I'm going to flip the equation around. You don't need to, but lots of kids like to do that. What does the left side simplify to, Mikey?
The left side was simplified so that we can
And what about the right side? Wendy?
put it by the 1 and 4.
Very good. What do we do to solve for n? What do we do for that? Place you.
We divide by 8.
Good. Good. And equals 13. So the product of the means and the extremes allows us to solve for unknowns in these proportions. Example 5, you can see it's kicked up a notch. You're going to end up with an equation with variables on both sides, which we worked out in the past couple of days. I want you and your partner to do 5 together, not individually in check. Talk together through it. When you agree on the answer, call me over. I'll give you your homework. You can start on it. Okay. And there is the solution of that example. Thank you. You may now begin.